Hello everybody, welcome to Dr. Kidio Math channel. This question is, it should be A-level pure math 1997, sorry. And this is question 1. This question is complex number. First, for any complex number, Z1, Z2, and etc. to Zn be arbitrary complex number. Prove that Z1 times conjugate of Z1 plus Z2 times the conjugate of Z2 equal to Z1 times Z2 plus Z1 times Z2, the conjugate of this one. And if Z is equal to cosine theta plus I sine theta, then the conjugate is equal to cosine theta minus I sine theta. That is a definition of conjugate. For this one, I try to prove that by using the converse, from the result to the beginning. Therefore, first I write down the sentence here, and then move this one to this one and this to this direction. Okay, no problem. And move all the stuffs to the right hand side, which is actually equivalent to greater than 0. Then that is minus. And for these two, I factorize the Z1 conjugate minus Z2. And for these two, I factorize the Z2 conjugate. And also factorize the left side outside, and Z1 conjugate minus Z2 greater than 0. And we can see that these two are same. Then I can factorize once more, Z1 minus Z2 conjugate times Z1 conjugate minus Z2 greater than 0. But actually, this is equal to, this is equal to Z1 minus Z2 conjugate times Z1 minus Z2 conjugate, which is Z1 minus Z2 all square. That is absolutely greater than 0. Therefore, we can begin with this one, and then by the definition of the the modulo of Z square is equal to Z times Z conjugate by using this definition, and then expand and change this one. Z, the conjugate can be move to this one, and then Z2, the conjugate Z2, the conjugate of Z2, then conjugate, then we remain it turns to the original Z2. And next, expand term by term. Expand this term by term. Becomes this one. And finally, this is the result we want. Okay, for part B, let me see. For part B, I try to write, change this one. Because this format can be think as Z1 square, the modulo of Z1 square plus the modulo of Z2 square greater than this one plus this one. This is actually equal to two real part of Z1, Z2. In this case, for the part B, we can group that term by terms. That means 1 over 2 2z1 square plus 2z2 square z1 square. Then z1 square group term by term. In this case, I group that z1 and z2. This is one term, this one group. And then the second group, z2 plus z3. This second group, then the this n. Then the last two terms is zn subscript of n minus 1 square plus zn square. The last one, zn plus z1, this one. Then finally, by the part A, this is greater than. This greater than 2 real part of z1, z2. This is greater than 2 real part of z2, z3. And etc. And 2 real part of zn plus z1. Zn times z1. Yeah, as the operator real part can be factorized outside, and also the 2 can be cancelled with this one. The outside the denominator 2, and change the real part outside. Then we got our result. Okay, that is the solution of this question. Okay, I hope guys can enjoy this video. That's my first time to present the A-level pure math question. I hope guys, I hope you can support this channel. And if you found Dr. Katie Math channel is useful, please subscribe my channel. Bye bye.